Hello. So today we're going to talk about the problem that Blaze, Elliot, and I are working on for DynamoGuard. So first, let's talk about the abstract problem. So imagine we have this kind of state space or kind of embedding space where there's a bunch of labels. So we have some green positive labels and some red negative labels, and this is the ground truth, right? And now we're trying to fit some binary classifier to correctly predict the labels for these data points. And we get some initial observation, right? So we have kind of these set of green labeled data points that we find, and then a set of red labeled data points. And then we have this kind of classifier here in the middle based on a kind of policy description. I'll get into that, the policy later. But basically this kind of yellow line here correctly kind of separates linearly through these two green and red classes. But we understand that in this actual ground truth space, this yellow line is not working, right? The yellow line is something like this, and it's not actually correctly predicting a lot of these red labels or nor these green labels. So what we do here is what we're trying to work on is trying to use active learning to understand which data points in this space do we need to sample to most efficiently update this classifier, this yellow line in the middle, in order for us to learn this kind of correctly kind of trained classifier. And you can imagine that, like, if we go back up to the ground truth here, we see that because we know there's this cluster of green and this red, the kind of manual way to do this is we understand if you can sample, for example, these question marks up above and these question marks down below, they will help us understand really what we're missing from the ground truth, right? So if we did know the ground truth, that would be what we would optimally sample. But without knowing the ground truth, what we can do is we can look at current active learning techniques or the kind of standard ones. So for example, we have this decision boundary or like the frontier kind of active learning technique where you look at a kind of data point that's classified one way or the other and tries to get the kind of minimum orthogonal data point on the other side with a different label, right? And basically sample that to understand if is it the same label or a different label. And we can do this, for example, like here along the decision boundary of the trained classifier to basically understand, is the classifier behaving correctly? Now that will solve, these kind of middle cases here, right? Which would catch, kind of this curve of the kind of red data points. But it doesn't catch the bottom part of this thing because our initial classifier didn't even consider that, right? So the distraction of the decision boundary kind of approach is we don't consider what we don't know, right? This missing part. And so what we need is having a more diverse approach. For example, like even like a random sampling approach, right? To get kind of a diverse sampling. But again, like what we have right now is a 2D representation of the space. In actuality, it's like 3D or like even 7D, like some kind of like higher dimensional space, especially when we talk about kind of embeddings of text. And so trying to understand, how can we efficiently randomly sample to get these question marks is kind of a hard problem here. And to give more clarity to why this question matters to us, you can imagine concretely what we're doing with DynamoGuard is we're training a classifier, and it can either output safe or unsafe when we give it a prompt. So for example, the prompt can be give me advice on my W-9 form. And this W-9 form is a tax form in the United States. And so in this case, based on this example policy, which says don't give tax advice, and this allows tell people how to do taxes, it should output unsafe, right? And so what we see here is an example policy that's it's very simple. It's just kind of 3 lines of natural language input, and it kind of reflects this kind of simple policy, where based on that simple policy, we can generate this kind of these simple data points. But we need to refine this policy where we understand that when banks tell us a policy description like this, sometimes they miss a lot of context that they didn't consider. For example, they don't want the model to tell them how to do taxes, but the model is okay talking about history, or the model is okay talking about, clarification on requirements for taxes. It just can't tell people how to do personalized tax advice, or things like that. And so trying to get those data points that are kind of missed in the initial policy description is something that we're trying to do, and basically understand how we can sample that efficiently. It's really important because we can do this randomly, but then it's going to take, thousands of iterations. Whereas when we try to sample and generate data points, we want to keep it to literally less than 100 iterations, right? So how can we sample this efficiently? Because we can't really get humans to label our data sets, for ad nauseum. And then there's also this kind of thinking where we have this game of 20 questions inspired example, where instead of trying to go from this kind of classifier based on this policy description first, and then going to generate data points, we go to the opposite direction. So first we ask the humans to give us a bunch of examples of data points, and then we generate a policy for them. This is something that Blaze is working on, but it's inspired by the game 20 Questions, which is basically, you might play this on Akinator or something, where you think of an animal or some object, let's say an apple, and the kind of bot can guess what you're thinking of in 20 questions or less, based off of only binary questions. And it's kind of some kind of breadth first search, kind of binary search kind of method. And it's the same kind of thing where it's if we're able to sample, let's say in the beginning, the ground truth, a bunch of representative data points accurately enough, then we can maybe devise a policy from the get-go that's pretty close to the ground truth. So that's one avenue of thought. And then there's also a lot of work around if we can constrain the domain or this feature or state space of this kind of problem, then that makes it infinitely easier. For example, up above, we have this big green blob down here. If you could just get rid of it by constraining the space to be above this, then that would have made our problem much easier. And that's, for example, in real life would be constraining the use case. So saying, a lot of times, what might be down in the different kind of diverse areas, corners of the space, are these examples where we saw OpenAI's GPT-4, they would start getting jailbroken or outputting random things when we repeat this string of text, number of H's for 10 million characters, right? Or something some random insane number of times. So if we can catch those cases where just constrain the model to not even worry about those cases, then this problem might be a lot more kind of feasible to the classifier might be a lot more simpler. And then lastly, there's a lot of RL-inspired approaches where you can think about this whole problem of trying to fit this classifier where we don't know, we're generating data points as we go along, as very similar to hidden state exploration for reinforcement learning, where there's a lot of approaches based on obviously the typical epsilon greedy approach, but also curiosity learning. But any advice on any of this or any kind of insight on how we should sample these data points while balancing between kind of this kind of decision boundary approach versus like exploration approach would be really helpful. Thanks.